everyone. For the next session, we're doing a rerun, a little throwback, let's say, from a previous NANOG. We have selected one of our best talks from NANOG 68, Desperately Seeking Default from Jeff Houston. Thank you.
Thank you, everyone. My name's Jeff Houston. I'm with APNIC. I play with numbers. You know, I have to thank Scott. I lived through a lot of that myself, and I must admit at the time, I had no idea what was going on. It was all a blur. I was even on that international ad hoc committee. And I remember at most going to a meeting in January in Geneva, and there are many places on the planet that you can go to in various times of the year. Don't go to Geneva in January. It's really cold. But beyond that, I'm not sure I learned much. This talk is quite different to Scott's. This is actually a talk that I hope is a lot nearer and dearer to your hearts if you're running an ISP, if you're in the peering and transit business. And this is actually a talk about connectivity. You see, although the internet is not the telephone network, and as Scott said, it's built in a remarkably different way, different players, totally different regulatory structure from the sort of superficial aspect, we're in the same business. We're in the business of communications. And interestingly, the 140 odd years of telephony created a number of points of ethos, what we regard as essential for a public communications network. And one of them was almost an unconscious thing. If I had a telephone and you had a telephone, we could ring each other. There's nothing stopping it. All telephones are equally reachable. Now, in the early days, that wasn't the case. You know, your telephone company didn't talk to mine and so on and so forth. But in the massive reforming of the telephone business in the early parts of the 20th century, the emergence of ATT in the US, one company, one service, one realm of connectivity. And then when international subscriber dialing came along, that became a global commitment. That your telephone company talked to my telephone company, your phone could call my phone and vice versa. Anyone could dial anyone else. And we think that's something we need, yeah? So when we look at the internet, is that the case? When I turn my Macintosh laptop thingy into a web server right here and now, can all of you reach it? Can the world reach it? Are all these connected endpoints equally reachable as per our expectations of telephony? Because the internet we thought we were building mimicked telephony. All of these IP addresses are equally routed and all of them are equally reachable, aren't they? You meant to say yes at this point, because that's what we expect we're building. That's why you go to all this trouble with peering and bringing up upstreams and creating connectivity and trying to grab all these routes, because you're trying to actually get universal connectivity, yes? Well, you know, the first point is all connected endpoints aren't equally reachable, and you know that as well as I do, because everybody runs NATs and firewalls. Because all of a sudden, the peer-to-peer network that we were building a long, long time ago is not the network we have now. We shifted huge amounts of the internet into client-server-based architectures. So all of a sudden, this is now a different network to the network we had. If you're a client, people can't get to you. But the theory goes still, and we still fervently believe that if you are a server, if you stand up a service on port 80, or maybe that's just old-fashioned, you stand up a service on port 443 and you sit it outside of a NAT, then everyone can reach you, right? Because at least we've managed to salvage that little bit of the universal connectivity ethos, yes? Maybe that's the new internet we want now, that no matter who you get your transit service from, it's equally good and that everyone can get to it, yep? Yes? Well, this is what you expect, right? And so I'm kind of looking at this, you know, even if all these points aren't equally the same, all the servers, can everyone reach all the servers? Well, I'm kind of wondering about this. And you start to look for evidence. Because what I'm trying to see is that really the case? Can I reach everywhere? Now, to digress a little bit, I do a lot of internet measurement because it's fun. And Google helped me a lot. Thank you, Google. Because one of the things that gets you to run code on everybody's browsers all of the time is Google's ad network. Now, Google might do a lot of things, and they do. 97% of their revenue comes from advertising. So they really, really worry about ads. They try and make sure that as an advertiser, you get precisely the eyeballs you're after. So when I come along to Google and say, I want to see everybody, they're really, really good. They go off chasing everybody because that's who I asked for. Thank you, Google. They're fantastic. The other thing about Google, which I really love, like any advertisers, is that you only pay for clicks. If you see that ad, for God's sake, don't click. Just let it go, right? The code will always run on an impression. If you click, I pay more. That's a bad thing. So up comes this ad. What does this ad do? Well, all ads have code in them. All of them. They make the mouse go funny. They highlight stuff. They watch you. All ads are loaded with HTML5. So is ours. And that's what it's loaded with. A collection of, I think there's about 12 in there, URLs that your browser fetches. They all point at servers that I run. And the servers that I run PCAP and capture everything. So I'm seeing a total log of what folk do when they try and fetch those URLs. So that constantly records. So that's a lot of activity. We do around 5 to 7 million separate experiments a day. Thank you, Google. And it doesn't cost a lot because no one clicks on the ad. Great. Love it. So we see a lot of the internet. And the other thing Google really do, if you notice, is that certainly as an advertiser, they try to deliver fresh eyeballs. So the 7 million I see tomorrow are not the same as the ones today. And the ones after that are different, and so on and so forth. So you get to see all parts of the internet, from the Faroe Islands through to somewhere deep in Zimbabwe. You even get ads in Australia. No matter where you are, even in China and even in North Korea, you find that someone's watching YouTube, ads come up sooner or later. We get to see most of the internet eventually. So that's what we see. One part of this ad is a TCP connection. Now, some of you did this whole protocol dynamic stuff, remember that? And you might recall that the initial part of making a connection is a three-way handshake. The client sends me, the server, an open. It's called a SYN. So I see that packet, I respond with an acknowledgement of that SYN and send my own magic number called a SYN-ACK, and I'm waiting for an ACK. And then we go off and do the whole HTTP dance and we all have a good time. But sometimes I only see the one packet. I see an incoming SYN, comes to my server, I send the SYN-ACK, nothing happens. So I'm kind of interested in that, and I started to measure them. Now, anyone running 6 to 4? Good, because it sucks. Its failure rate is around 10%. So, you know, if you hate your customers, run 6 to 4. It's just horrible. It really is the protocol from hell. IPv6 itself, the average failure rate isn't 10%, but it's still pretty bad. The failure rate of IPv6 these days is 1.5%. Now, as I said before, we have this ethos from telephony, yeah? Universal connectivity was one of them, 5 nines is the other. Anyone down there in engineering knows that your target for availability is 99.999%. Sort of 1 day in 10 years outage at most. That's what you're striving to do because it's connectivity. This is a public service, it needs to be up. V6 runs a 1.9 service because that's not 99%, that's 98.5, 1.9 service. You couldn't run a commercial service with that kind of failure rate, but that's what V6 delivers. And the only reason why this is not a complete disaster is thank God for dual stack, because V4 saves you. Because every single time this V6 connection fails, V4 comes along and goes, yeah, that's fine. I'll pull you out of that hole. That's an astonishingly big failure rate. And you kind of wonder, why are we building such a shitty network? No, truly, how can you make 1.9 a target? Because it's not a target, believe me. You might be professionals, you might be good at what you do, but 1.9 is not what you're trying for. So why? Now, some of it's auto-tunnelling. You know, even 6RD isn't brilliant. Don't do this stuff. A lot of it is lousy CPE. You know, the Internet of Things is upon us. The things that we have are already crap. Building more of them isn't going to help you, but we seem to believe somehow that 20 billion of them will make life better. It won't. And by the way, most of you can't program firewalls. You know, you just can't. So a lot of that is the problem down at the end. But when you think about it, you kind of go, well, if we're doing such a lousy job in V6, are we doing any better in V4? Because like I said, thank God for dual stack. But is the V4 side of the equation working? It's not 5 nines. It's gone from 1.9 to 2 nines, because you're professionals. So you're getting around 99%, but it's only 99.8%. There is still this astonishing 1 in 500 failure rate. And when you see failure rate like that, that's steady and consistent, but every day I'm sampling different people. It's a new 7 million the next day, and I'm seeing this really consistent level of underlying connection failure. Something structurally is broken in this network. So I don't think it's any auto-tunnelling. I don't really think it's shocking CPE. I'm like, maybe it is, but if you can't do 4, why are you selling a product? And, you know, I would have thought you got your firewalls right for V4, because if you haven't got them right, you're not seeing anything. So it's not the reasons why we say V6 is busted. We can't say it's someone else's fault. It's our fault. So then I go to the next thing that kind of binds us all together. What makes this one internet rather than lots of little internets? What makes it cohesive? It's the routing system. So let's look at the routing system. Now, there are 2 massive projects out there in the world which have been going on for some time, which are brilliant for this kind of work. One of them is University of Oregon's Route Views with Dave Meyer, and it's fantastic. And the other one is the RIST, Routing Information Service, one by RIPE, the RIPE NCC. So I just looked at the history of the number of routes advertised towards those 2 route collectors since 1994. And as you see, there's a lot of data inside those graphs and extends over a lot of time. The entire history of the internet is written there, even including the great internet bust of the year 2001. Ever remember that? You can even see the bust of 2008, 2009 if you look hard enough. So, a lot of data is hidden there. But let's just blow this up over the last 18 months. You don't have the same internet. Every single peer is advertising a subtly different collection of routes. And there's actually 2 bands there. Over in America, because you've got to do things bigger and better than the rest of us, consistently you're seeing another 50,000 routes more than anyone else. Down in Europe, it's slightly less. The RIST collection is the band at the bottom from RIPE, the route views is the band above it. The variance is 100,000 routes. And we only have 600,000. So that's pretty amazing that we see astonishingly different views of the same internet. Folk are seeing different networks. And you kind of go, well, maybe it's just more specifics, because everyone does traffic engineering in BGP because A, you can, B, it's cheap, and it's great to make your problem somebody else's. So to stuff it in the routing table, if you can't put it in the DNS and your problem's solved, right? Well, obviously, that's why you're here. So the thing that I'm kind of wondering about is, well, okay, you're playing with address advertisements. Are you playing with basic connectivity? Are there addresses that are reachable by some and not by others? So this is the same data looking at the total address span from each peer. And it's pretty clear you don't see one internet. It's pretty clear that there's a /8 that changes 15 million addresses across each of those peers. So I can be in your routing table and not in yours, and we think that's okay. And if you look at that banding, it doesn't change. Whatever the problem is, you're not trying to fix it. You're not even remotely thinking about fixing it. It's the same tomorrow, it'll be the same the day after, because you're not looking. So everyone announces a subtly different collection of addresses. They agree to within about 20 million addresses, so, that's okay, isn't it? And it's stable, so no one's trying to fix it. And it's not a routing problem. It's the way in which you build default. It's the way in which you build your connectivity tables. And around the edges, they're different. But, that was V4 and that's old and that's all history and no one needs V4 anymore, yada, yada, yada. V6 is all bright and shiny and all problems will be cured in V6, right? Yeah, right. We are consistent as an industry. We keep on making the same mistakes because we're bloody good at it. And this is the route views of V6 and it has exactly the same sort of sets of issues. And in fact, I think the span of address announcements is even greater than in V4. The number of V6 routes varies by 2,300 and we're only announcing, 20,000 of them. So, fantastic work, everyone. Well done. And if I look at the number of addresses being announced, again, the core variation is around 1,000/32s. So we can't even get that right. It's exactly the same set of problems. So then you go, well, what is the internet? I set up an ISP. Well, obviously I'm trying to tell my customers no matter where you send your packets, I can deliver them. I need to buy default. I need to buy service from transits and upstreams and peers. I need to assemble a full route set. But I have no clue what that means. And neither do you. There's no default that we can agree on, obviously. Obviously, you all have very different views of what default is. So I decided to define my own. So what I did is I took the collection from route views and risks and said, look, if 2/3 of the peers say they can reach an address, I'll put it in this magic bucket called default, and all the rest is not. And then I look at each individual peer saying, well, what extra routes do you have and what addresses are you missing? What's the variance from the mean? And that's the same picture, but this time taking for each individual peer how many addresses they have more than default and how many they have less. We will name the guilty later. But as you see, it's stable. No one tries to change the problem. It persists over time. Even if you magnify it up, it looks more like a Jackson Pollock painting than anything else. But you still see this kind of stable pattern of difference. What about V6? Well, the thing about V6 is when you advertise a /20, it goes off the graph. So, it's kind of hard to get the picture. But if you zoom in a lot, you'll actually see V6 is getting worse, not better. Because, we can, and we're good at our job. So who's doing this and why? So I started looking at this. And certainly there are some interesting answers. Telenet, very big transit provider. Compared to everyone else, it's missing 45 million V4 addresses in its route set. I have no idea why. I'm not sure they even know. Even level 3 is down by 2.5 million addresses, and I'm not sure they even know that they are. And they're certainly not trying to fix it because they don't know it's a problem. So if you're on this list, you should kind of think about it a little bit, going, where and why? What is going on that this is different from other people? I did the same for RIS. If you're on that list, you're probably somewhere in Europe. And again, it's kind of things are missing. I'm trying to think of one obvious one. Level 3, again, is missing 2,500. I saw one there. This is the same in V6. So again, even in V6, like Hurricane Electric, there's a bunch that's missing and a bunch that's more than the core. So none of us can agree what default should be. The same in RIS from RVA. We see this across the entire internet. So it's structural. It's not a routing problem. It's not a ghost route. It's not some artifact of BGP. Because I think you guys assume something that isn't true. When you look at making a choice between two upstreams, you kind of assume they're offering you the same route set because they're an upstream. They're offering default, right? So there must be an equivalent offering. They're not. Those defaults will differ because default varies. AS2914, you know who you are, NTT. In route views, you advertise 2.808 million addresses, 2 billion addresses. In Europe, you're down 1 million. Same provider, same AS, subtly different route span to each of those collectors. I have no idea what's going on. I hope they do. But what it really says is, we're not sure that we can actually understand what universal connectivity is all about. And I suspect that this is a very subtle form of market failure. Because unlike the telephone world, unlike the whole regulated and arbitrated connectivity that telephony insisted upon, in the internet, this is a market. And there's no global routing arbiter. There's no way that you can get all possible routes as a regulated outcome because none of us actually know what that is. Default is a market outcome. You buy services from a transit and you kind of hope that it kind of will get you everywhere, but you don't know. And you kind of hope that if you can't get somewhere, your customers will ring you up because after all, that's the folk you use for all of your testing. And so you advertise your route into that upstream, hoping that that means that everyone else can reach you. You hope, you have no idea. You have no clue that that's actually going to happen because that's not an assured outcome in the internet. The edges aren't good. Now, I've seen talks by Randy on this one talking about how the actual use of a default route in routing patches all this up. And the whole idea is that if you sit inside a tier 1, it really doesn't matter anymore because everyone points a real default route up, further up the tree and you're just fine. That's fine if you're a tier 1. That's fine if you're Akamai. I'm not. I live further down the food chain with my servers, so what I see is 2 nines availability. That of the internet, I get 0.2% drop rate of folk trying to see me. And I kind of think there's a certain amount of connectivity failure going on. Can I confirm that? Wow. Well, again, let's have a look at what's going on here. I see a SYN, I send back a SYNAC, it gets dropped, right? Standard stuff. But what happens then is that you get back often a little message, because ICMP is my friend. Because whenever a packet gets dropped because it's not in a routing table, the router will, occasionally if it's friendly, send me back a little note going, you couldn't get there, Jeff. And what I see is ICMP destination unreachable, right? Well, I do. I see a fair few of them. They don't quite match the 0.2% because some folk like to filter ICMP, God knows why, it's a helpful little signal. So what I see is destination unreachable in the outer packet, and the inner packet is that SYNAC that never made it back. That somewhere, 84.41.108.74, thank you very much, didn't have a route to 46.163.63. whatever, and just couldn't make it any further. The packet goes on the floor, no one actually manages to make it through. And so there's a fair deal of that going on in the silence of the internet, right down at the packet level that you and I can't see. So the conclusion sort of is that if we really think this is a network that has universal connectivity, we're kidding ourselves. Because it's kind of 2 nines, right? It's sort of, well, you know, within 2 nines it's true, but it's kind of almost anyone can sort of almost get to everywhere else most of the time except those few people up the back. Sorry about that. Didn't mean it. And no one complains. Your help desk never, ever, ever gets the call. Why not? Because nobody cares. Why? Because we're not building a peer-to-peer network anymore. We stopped building that years ago. We're building tier 1 feeder networks. If you can't reach Google, you'll know about it. Your help desk will melt. If you can't reach Akamai, Netflix, Facebook, and all the rest of them, your help desk will melt. And you'll know there's a problem, and you would have fixed it, because that's your money. So if you're working towards feeding tier 1s, you know where your job is, and you will fix it. And so the network we have today is a subtly different network from telephony. Or maybe it's not so subtle, maybe it's quite brutal. Because the network we have today is a CDN feeder system. A system that feeds your clients in towards concentrated points of content very, very well. And acutely well, really reliably. Your customers are looked after, facing towards the tier 1s and coming back. But talking between ourselves, what we used to think the internet was all about is becoming increasingly not a goal. It's not something we're trying to build. It's not an outcome we're actually trying to engineer anymore. The network we are building is now a unidirectional network that points up towards tier 1s and back, and that's it. Now, for an old fart such as myself, that kind of makes me sad, because, you know, I kind of thought we could do better than that. I actually thought if we could do better than telephony, that we could take that ethos and make it even better. We can't. We don't seem to be doing that. And, you know, maybe I just have to get with the times and accept it, that if I really want my content to be seen by everyone, I need to buy my services from a tier 1 CDN, because I can't do it myself anymore, because not everyone can see me and not everyone can see you. Thank you.